Okay, so I want to make this Unit 5 video so you guys can review. You guys have your review that you need to finish up for Unit 5. You guys have some studying you have to do, get any missing assignments in. Last but not least, to make sure that you guys are ready for the Unit 5 test, I made the Unit 5 review, okay? So, as always, I'll separate the chapters of the review in the play bar of the YouTube video. So just click on the play bar, see what you need help with, and you know, if you need help more with force diagram still, if you need help with the summation of forces, if you just need some practice problems, okay, just skip to the part of the video you think would help you the best. Hopefully you don't have to watch the entire thing. And again, I'll try to keep this to a shorter length, okay? So this is Unit 5, Unbalanced Forces, okay? So we're gonna start in the top left. Now, in top left up here, what does a force arrow tell you? So for example, if I have a force arrow and I have an arrow going to the right and an arrow going to the left, and they both have a little tally on them, they have a dash mark, okay, what does that tell you about these two forces, okay? Now, if a force has a dash mark on either of the arrows, okay, if they have a dash mark on either arrow, that means they're equal in magnitude for the force, okay, that's being applied. So, since there's a force going to the left and a force going to the right, and they're kind of canceling each other out, okay? What that's saying is my force left and right are equal, but since they're opposite, they're going to cancel each other out. My net force is going to be 0, okay? Net force of 0. And that's because if you have two things pulling on an object, one in one direction, one in another, okay, and they're equal forces, the object isn't going to move. So if you have a summation, okay, net force or a summation of forces that is 0, that either means your object is not moving, it's either not moving, or it's not changing speed. So it's not accelerating, okay? How about if we have an arrow just facing one direction, okay, and we don't have any other arrows to cancel it out, okay? So if we have an arrow forcing one direction, well, that means there's only a force being applied to the right. If there's a force being applied to the right, all the force is going to be going right, and that means my object is going to be accelerating to the right, okay? So if you have a force diagram where an arrow is just going right, just going up, just going left, just going down, or going at a diagonal, okay, that means that you're accelerating in that direction, okay? And that also applies if you have a force diagram where if you have one arrow going this way, one arrow going this way, and this right force is greater than the left force, that means we're going to be accelerating this way. Because it's a greater force going that way, we're going to be going faster and faster that direction, okay? So we're going to be accelerating that direction. So this is what force arrows tell you, okay? If they equal out, you're not moving, or you're not changing speed, okay? If you have one arrow that overpowers another, or if you have one arrow and no other arrow to cancel it out, that means you're accelerating in that direction, okay? So with that being said, we're going to go into our first practice problem. So I'll zoom in just a smidge more. There we go. So, a construction worker uses a frictionless pulley to lift 200 kilograms worth of bricks up to another floor. The worker pulls on the rope and accelerates the bricks up at 1.8 meters per second squared. Okay, so I have my pulley, the worker's over here, and he is going ahead, and he's pulling this string, and he's causing the bricks to go up a higher level, okay? So first we're going to draw a force diagram, okay? So my object in this scenario is going to be the bricks, and they currently have a mass of 20 kilograms. So mass equals 20 kilograms. Well, he has to pull it up, and the reason he's pulling it up is because the bricks aren't going to magically float up there. So that must mean we have the force of gravity pulling down on these bricks, force due to gravity. And he's pulling up the bricks, okay, with a pulley string, so that's going to be force tension. Okay, don't forget your on-bys. So gravity's pulling down on the bricks, and the thing that's causing the gravity is the earth. So this is a relationship between the bricks and the earth. And then the rope is pulling up on the bricks upwards due to the tensional force from the rope. Okay? If I wanted, I could find some of the forces. I can calculate what their newtons are, and I will have to do that for part B. What is the tension in the rope? So I want to find the arrow going up, okay? So to find that, I only have 2 arrows so far, and I have FG going down, and I have FT going up, and it gives me the information that we're accelerating up at 1.8 meters per second, okay? So I know I'm accelerating up 1.8 meters per second squared. I know my mass is 20 kilograms, okay? To find Fg, force due to gravity, that's the classic equation of mass times gravity. And if I'm going to find my force going up, I'm going to have to use acceleration. So I'm going to need my force equals mass times acceleration equation. And so how am I going to solve this? Well, first, what I'm going to do is find my summation of forces. Okay, which 2 forces am I dealing with? So my summation of forces, summation of force in the y direction, because we're going only up and down, my Ft minus my Fg is going to equal my force. So it'll tell me whether I'm going up or down and whether I'm going to be accelerating up or down. Okay. So first thing I'm going to find is my Fg here. Okay. To find Fg, I need to do Fg equals mass times gravity. Luckily, I know what the mass is, and gravity is going to be the same in this scenario as it is on really anywhere on this planet. So Fg equals mass, which is 20 kilograms. Now it'll be multiplied by 9.8 meters per second squared. Okay. If you do that, your Fg value should be, I believe it's 186 newtons. Let me make sure that's right. I have some of these numbers prepped. I am wrong. This is why you have the numbers prepped. 196 newtons. Thank you, pass Mr. BB. So Fg equals 196. Okay. So I'm going to plug that in for here. So Fg is 196 newtons. Now, when it says summation of force, okay, this is force in the y direction. I'm just talking about the force in general for this scenario. So my forces I'm dealing with so happen to be y direction forces, up and down. So Ft up, Fg down. But I'm really just trying to find which direction is my force being applied to the most. Okay, and this is where my equation at the bottom is going to come in handy, because summation of force is the same as really force right here. Technically, this is just a summation of force. So if summation of force equals m times a, I could just put m times a over on this side. M times a. Okay? So I know my Fg was 196. I'm going to subtract that from my Ft. I know my acceleration in this scenario. It says I'm accelerating 1.8 meters per second squared upwards. And my mass is 20 kilograms. So I'm going to take these 2 numbers and multiply them together. Hopefully Mr. BB has it this time. I believe this is 36 newtons. Yes, very good, Mr. BB. So 36 newtons from this equals F tension minus 196 newtons. Okay. And so again, I set this equation. This was summation of forces, Ft minus Fg equals the summation of force in the y direction. But the summation of force is also equal to my mass of my object, which is 20 kilograms worth of bricks, times the acceleration of the bricks. And it says I'm accelerating the bricks up at 1.8. So 1.8 is my A, times 20 kilograms is my M, got 36 newtons. Now to find Ft is currently being subtracted by 196, so I want to undo that. So I'm going to move the 196 over. So plus 196 newtons on both sides. If you do that, again, pass BB, Mr. BB, thank you so much. 232 newtons is my Ft value. Shwoop, shwoop, shwoop. It's pretty good. Now, this can be tricky because, again, summation of force is when you're going to take 2 forces, like Ft, and subtract it from Fg, okay? And to find whether I'm accelerating in a specific direction or if I want to find the force in the direction, I may have to use my F equals ma, okay? And then I set that equal to whatever my summation is, okay? So, I know that can be tricky, so that's where we're going to keep practicing on this, okay? Ooh, this is a fun one. Elevator problem. So, a person stands on a scale in an elevator, okay? The scale reads 615 newtons when the elevator isn't moving. What is the acceleration of the elevator if the scale reads 700 newtons? Okay, draw a force diagram to solve. So, first I'm going to identify a few things. It says when the elevator isn't moving, we read 615 newtons. So that means the force due to gravity, when the person is standing on the scale, okay, when it's not moving, is 615 newtons. Okay, we want to know acceleration. What else do we know? Do we know anything else? I don't think so. So, force diagram, let's get this started. So we have a person, and when the elevator isn't moving, okay, their force due to gravity is 615 newtons. And again, that's caused by the person being pulled down due to the force of gravity by the earth. And then they're not falling to the floor of the elevator, so the elevator must be pushing up, okay? And so when the elevator's not moving, when it's not moving, it's not accelerating in any direction, the force going down is going to equal the force going up. But they say when the elevator is moving, okay, or when the elevator is accelerating, the force normal, the scale, reads 700 newtons going up. 700 newtons. And this is going to be a normal force. And this is going to be the scale pushing back up on the person. Okay? So, we can get force of gravity, the normal force of gravity, from the person standing on the scale when the elevator isn't moving. But then the elevator starts accelerating, either up or down, we don't know yet. And when it is accelerating, the force normal going up is 700. Okay, so we have a greater upward force. Now, how do we want to solve this? Okay, we got to find acceleration. Now, acceleration can be solved from our classic equation of F equals m times a. Now, here's the problem. I don't know the mass of this person. Okay, we don't know the mass, but we can find the mass. Okay, to find the mass, we need to take our classic FG equation equals m times g. Now, Fg is the force going down that the person has, okay? The force due to gravity. And we know that's 615. That's how much they weigh in newtons. That's their force going down in newtons. We don't know their mass, but we do know that gravity is 9.8 meters per second squared. So to solve for m, I just need to take 615 divided by 9.8. Keep saying 18, 9.8 meters per second squared. And if you do that, your mass is going to be 62.76 kilograms. Okay, now I know the mass of the person. I need to find the acceleration. And I need to know what the force is, okay? Specifically net force. So, where am I going to take this from here? I'm going to erase this. There we go. I'm going to keep this mass number because now I know what mass is, so I'll put that over here. Mass equals 62.76 kilograms. Okay. Now, if I want to use my force, equals ma equation, I need to figure out what the summation of forces going up and down. Okay. So I need to take my force going up and subtract it from my force going down. So summation. If I take 700 and I subtract it from 615, because I'm going to consider that 700 in the up direction is positive, 615 in the down direction is negative. So I'm going to take summation of force equals 700 newtons minus 615 newtons. That'll give me what my summation of force is, my net force. And that should be 85 newtons, okay? And this is specifically going up because this is a positive number and I'm considering up as the positive direction, okay? I'm considering down as a negative direction, okay? So if I have 85 newtons and that's positive, that means I'm having a force going up, so I'm probably going to be accelerating up. Okay? So, summation of force equals 85. I'm going to plug in 85 right there for my summation of F. So, right here, my force, I'll just erase all of that. My force equals mass times acceleration. Force is 85 newtons. My mass is 62.76 kilograms. Acceleration is unknown. That's what I want to find. If I'm accelerating, how much am I accelerating up by? Okay. So to find acceleration, I need to divide both sides by 62.76 kilograms. If you do that, your acceleration should equal 1.35 meters per second squared. And since the acceleration is positive, that means I'm accelerating up in the positive direction. Okay? So again, for these problems, don't forget that you have to assign a direction, positive or negative. So I'm saying that the positive is up because that makes sense to me. If you're going up, that's positive, and it makes sense for me that if you're going down, that's negative. Okay? So again, another summation of force problem where we're going to have to put the summation of force, which is Fn minus Fg, is going to equal my ma. Okay? So you have to combine those equations to often find a missing acceleration or a missing force. Okay? And we're just going to keep practicing on this. Here's another one. So I pull on a 100 kilogram fridge horizontally, so horizontally means flat, left and right, okay, with a force of 620 newtons across a flat floor at a constant speed. Draw a force diagram and determine the coefficient of friction, okay? So this object right here is going to be my fridge. The fridge has a mass of 100 kilograms. Now it says I pull on the fridge horizontally with a force of 620. So I'm going to say I'm going to pull this way. Since I'm pulling, it's going to be a tension force. And this is going to be with 620 newtons worth of force. Okay, and this is, let's say, a rope I'm using, pulling on the fridge. Now it says it's being pulled across a flat floor at a constant speed. So constant speed, as we know, means same speed. We're not changing speed. So if you're not moving or you're not changing speed, our summation of force in the x direction is going to be 0. So my right arrow must get canceled out by a left arrow. So I'm going to do that. So I have a right arrow. It's going to be canceled out over here by a left arrow. And this left arrow is going to be due to friction. Okay, and that's going to be 620 newtons. And so that's the floor causing friction with the fridge. Okay, and so these two are equal, so I'm going to put a little tally there. Now the fridge isn't flying off into the sky, so there must be a force pulling down due to gravity. And that's the earth pulling down on the fridge. And the fridge isn't falling to the floor, so that means the floor is also pushing up with the force normal. So the floor is pushing up on our fridge. Now if I want to find Fg and Fn, okay, these two guys right here are going to be equal, and the reason is it's not falling to the floor. It's not going to launch into the air. So these two must cancel each other out. Can't really find Fn because it wasn't given, but you can find Fg as long as you know that Fg equals mass times acceleration due to gravity. So I'm just going to put the g here. Well, I don't know what Fg is, but I do know the mass of the fridge is 100 kilograms. And this will be multiplied by the 9.8 meters per second squared. Okay? So I'm just taking 100 times 9.8. So that'll give me an Fg value of 980 newtons. And that's going down. So this will be 980 newtons going down. And that'll be 980 newtons going up then. These are equal. Now what I'm trying to find is the coefficient of friction. Now, to find the coefficient of friction, what you need to do is have the equation for it. Now, this equation will be provided on the test. The coefficient of friction equation is right here. So friction equals the coefficient of friction, also known as mu, times the normal force going up, okay? So the force normal going up. So if I want to find the coefficient of friction, if I want to find mu, okay, I need to take the force normal going up, and I need to interact with it with the force of friction going to the left. So I'll write that over here. So the force of friction equals the coefficient of friction times force normal. Well, the frictional force was 620. I do not know what the coefficient of friction is. The normal force was 980 newtons. So if I want to get the coefficient of friction by itself, it's being multiplied by 980, so I have to divide both sides by 980. So 620 divided by 980 is going to give you a coefficient of friction of 0.63. And the coefficient of friction, again, is telling you how grippy, how much that floor grabs on to the object when it slides across it, okay? So, for some of these equations, when you're finding the coefficient of friction, or if you're given the coefficient of friction, you're going to have to use the coefficient of friction equation. So, force of friction equals coefficient of friction times force normal, okay? That will be provided on the test, so will these other equations as well, okay? Lovely. Now, another problem. The world is just full of problems, so we're just going to keep using them. So, an 18,000 Newton box truck slows from 30 meters per second to rest in 17 seconds. Determine the net force on the truck. Okay, so this is where we're going to start using our motion equations. These guys right here. So velocity equals acceleration multiplied by time plus initial velocity. Final position equals 1/2 times acceleration times time squared plus initial velocity multiplied by time plus initial position. And last but not least, final velocity squared equals initial velocity squared plus 2 multiplied by acceleration multiplied by the change in position. Okay? So you have to identify, just like before in Unit 4, which equation we're going to be using and when and how to use them. Okay? So with that being said, let's start with this problem right here. So it says we have a truck. We're going to try to figure out what information we know based on what the problem gave us and what we can assume about said truck. A and T. So let's see if we can figure out any of these things. So, a box truck that weighs 18,000 newtons slows from 30 meters per second to rest. So we started with a velocity of 30 meters per second. And our final velocity was at rest, so we're coming to a stop at 0 meters per second. We want to know the net force. Okay, I see you. Net force is a big question mark. We did this in 17 seconds. We can say the initial position was probably, we can count it as the starting line, so we can say that's 0 meters. I can't figure out my acceleration quite yet, and I don't know my starting position. So the question is, what equation can we even use here? Based on the information I'm given. Well, I know starting velocity, I know ending velocity. I could assume starting position. I do not know acceleration, but I do know time. So what can I use here? Well, if I know time, I can use one of these two equations up here. But I do not know final position. I don't know acceleration. So I don't know final position, I don't know acceleration, can't use number 2. Number 3, I don't know my change in position, I don't know acceleration, so I can't use equation number 3. I do know final velocity, I do know initial velocity, I do know time. So I only need to find acceleration, so I can use that equation. Now you might be asking yourself, Mr. Beebe, why are we even finding acceleration? We're trying to find net force. Well, remember, net force equals mass times acceleration. If I find acceleration, if I find mass, I can find net force. So we're going to start by finding acceleration. So the equation I'm going to use is final velocity equals acceleration multiplied by time plus initial velocity. So my final velocity was 0 meters per second. My acceleration is unknown. My time was 17 seconds. And my initial velocity was 30 meters per second. So, first thing I'm going to do is remove this 30 meters per second. So I'm going to move that to the other side. So if I have a positive 30 meters per second on that side, I need to subtract it and move it to the other side. So I'm going to subtract 30 meters per second on both sides. So negative 30 meters per second equals acceleration times by 17 seconds. I'm going to divide by 17 seconds so I can get A by itself. Negative 30 divided by 17 is going to be negative 1.76 meters per second squared, and that is acceleration. So now I know that acceleration equals negative 1.76 meters per second squared. Now that I know that and I wrote that down, I'm going to erase all this guy. And now I know my acceleration right here. Acceleration is going to be negative 1.76 meters per second squared. Now, to find my net force, all I have to do is find my mass now. And I'm going to give you about 3 seconds. I want to see if you can figure out how can I find out what my mass is with the given information. Okay, let's see if you got it. Well, we know that the truck weighs 18,000 newtons going down, and if you're being pulled down with a weight of 18,000 newtons, that's a force due to gravity. If you use the force due to gravity equation, Fg equals mass times gravity, well, Fg is my 18,000 newtons. My mass is unknown, that's what I'm trying to solve, but my gravity is 9.8 meters per second squared. So if I want m by itself, and it's being multiplied by 9.8 meters per second squared, I'm going to divide both sides by 9.8 meters per second squared. I can't say that enough. So 18,000 divided by 9.8 meters per second squared is going to be 1,837 kilograms. And that's how, I shouldn't say that. That is the mass of my truck. So now if I plug that mass in, 1,837 kilograms, and I multiply it by my negative 1.76 meters per second squared, I can now find my summation of force. So if you take these two numbers and multiply them together, it's going to be a large number. It's going to be a very large number. It's going to be 3,000s, I'm guessing. It's going to be negative 3,233 newtons. Yes, very good. And since this is negative, that means my object must be slowing down. Okay, and that makes sense. Oh, not newtons, my bad. Oh no, it is newtons. So, it's negative, and since my truck, let's say it was moving to the right, okay, but it was slowing down, that means I'm accelerating to the left. And if I'm accelerating to the left, that means this arrow is greater. How much greater? This arrow right here is 3,233 newtons greater than this arrow. So this arrow is much smaller than that arrow, okay? So my summation of force is to the left, let's say for this example. So I was slowing down, okay? So that's how you can find a summation of force, or the net force, given Fg, your initial velocity, your final velocity, and time, okay? Again, just deciding which equations you're going to use in which moments. Okay, let's try this one now. A horse pulls on a 60 kilogram bale of hay that was at rest with 1,000 newtons of horizontal force. The coefficient of friction is 0.7, okay? So this is going to be a scaffolding problem. We're going to start with an easy question and get harder and harder and harder, and we're going to see if you can keep up, okay? So, draw a force diagram for this problem. So we have a horse. It's pulling on a bale of hay that was at rest, okay? and this is a 60 kilogram bale of hay. And let's say the horse is pulling this to the right. And the horse is pulling it from rest with 1,000 newtons of force. Well, since it's pulling, we can assume maybe it's pulling with a rope. This is going to be F tension. And this is going to be This is going to be rope. And this is going to be the bale. Now it was at rest. So the bale of hay was at rest. But now it's moving. Okay, and it's getting pulled. So there must be an arrow this way, but since it started at rest and now it's getting pulled to the right, that means it's accelerating. So I can kind of say confidently that these two arrows should not be the same because the bale of hay isn't going the same speed. It started at rest and then it's getting pulled, so that means it's sped up. If you're going any faster, then still you're speeding up, okay? And that's a frictional force that's going to be slowing it down a little bit this way. Last but not least, we have the force due to gravity, and that is the earth pulling down on the bale. I forgot my on-bys over here. This is going to be the ground pulling on the bale, slowing it down. And then we're going to have a normal force going up. This is the ground pushing up on the bale. Okay? And I can probably confidently say, since the bale of hay isn't falling to the ground and it's not getting launched into the air, that my up and down arrows must be equal. Okay? So the first thing I'm going to try to do is figure out what the frictional force is. So the question is, what is F? What does that equal? Well, to find FF, to find a frictional force, you need to use your force equation. So to find frictional force, when you take the coefficient of friction, which we were given, it's 0.7, and multiply it by the normal force. Okay, so we got to see if we can find that too. So the coefficient of friction equals 0.7. I need to get Fn. So I need to find that. And to find Fn, well, Fn equals Fg. So if I can find Fg, I can find Fn. Okay? So the bale of hay weighs 60 kilograms. And so that means the mass is 60 kilograms. So mass equals 60. So if the mass equals 60 kilograms, well, to find Fg, I can use my other force equation, which is force of gravity equals mass times gravity. So force of gravity equals mass, which is 60 kilograms, times gravity, which is 9.8 meters per second squared. If I multiply those two, my Fg value is going to equal, I apologize, I'm trying to find it right now, 588 newtons, and that's also equal to my Fn, because Fn equals Fg, okay? So my Fg value was 588 newtons. That is my Fn going up, which is 588 newtons. Well, now I can simply just use my equation, my force equation of force friction, which is what I want to know, equals my coefficient of friction multiplied by the force normal. So force friction I don't know, but I'm going to find shortly, equals 0.7, my coefficient of friction, multiplied by my 588 newtons of force going up, of normal force. And so if I take those two and I multiply them together, my frictional force will equal 411.6 newtons. So I can put that up here, 411.6 newtons. I can also put the 588 right here and up here. So I just solved for all my newtons. And that makes sense because the object was at rest and I'm pulling it this way, so that means it accelerated this way because it was at rest. And if you're moving any faster than still, then you're accelerating. 1,000 newtons that way, 411 that way, that means this arrow is greater. Makes sense. Okay, so my frictional force was 411.6 newtons. See, write a force equation for the horizontal forces. So horizontal forces means my forces in the left and right direction. And so if I do that, my force equation, my summation of forces in the x direction. Well, I'm going to look up above. I only have two forces in the x direction, so x is right and left. So I have an Ft force going right. And let's say right is positive, that makes left negative, so I'm going to subtract that from my force of friction. Okay, that's going left. And if you want, you can calculate a few things from here. So for example, I can put in the values to find out what my net force is. So if I wanted to find my net force, if I wanted to see how much stronger one arrow is compared to another, I'll put my tensional force, which is 1,000 newtons. I'll subtract that from my frictional force, which is 411.6 newtons. And that means my summation of forces in the x direction is going to be, what is that? 588.4 newtons, I think. That is I think that is right. So 488.4 newtons, okay, and this is going to go to the right, so that means I'm accelerating with a force given to the right. Now, last but not least, and this is kind of a scaffolding question that's going to require us to go back. But the last question is, how far did the bale of hay move if the final speed was 3 meters per second? Okay, so again, we're going to have to use one of our equations up above, one of our motion equations, because we're talking about the motion of the bale of hay. So I'm going to label what I have so far. I know in this problem the bale of hay started at 0. So we can say that the starting position was 0 meters. I want to know what the final position was. The starting velocity was 0 meters per second, because it wasn't moving. The final velocity, I do not know. I do not know final velocity. My acceleration, I do not know. My time, I do not know. Oh, wait. Nope, don't know time. And the bale of hay had a final speed of 3 meters per second. I actually missed that. So the final speed was 3 meters per second. So how far did the bale of hay move? Let's see, can I use any of the equations so far? Well, top equation, can I use that guy? Well, I'm trying to find how far did it move, and this one's all about velocity and acceleration and time. So that one I can't use because it doesn't have an x in it. Now the middle equation, x, final position, starting position, okay, that can work so far. Acceleration I don't know, and time I don't know. So I can't really use the middle one. Can I use the last one? Final velocity, I know that. Initial velocity, I know that. Acceleration, I don't know, and I don't know how far it traveled. So what am I supposed to do? Because I either need to find time, which you can't really find that, or I need to find acceleration, which I can find, because if you remember, summation of force equals mass times acceleration. Well, hot dog, the summation of force in the horizontal direction is 588.4. So I can use that number to help me out with mass and acceleration to find what acceleration is. So summation of force in the x direction is 588.4. And that's going to equal mass times acceleration. I know my bale of hay equals 60 kilograms. That's its mass. And acceleration I don't know. That's what I'm finding. But if I take my 588.4 divided by 60 kilograms, that can tell me how fast it was speeding up by. Okay? That's how I can find my acceleration. And if I do that, my acceleration is going to be, oh, what is this? I gotta actually use my calculator for once. It's kind of crazy, kind of bonkers. So if I take 588.4 divided by 60, my acceleration is 9.8. Ooh, ironic number there. meters per second squared. So I was speeding up in that direction with that much force. Now I know what my acceleration is. It so happens to be 9.8 meters per second squared to the right, so I'm speeding up that much. And now that I know acceleration, I can actually use the bottom equation now. So if I do that, I can use v squared equals initial velocity squared plus 2 times acceleration multiplied by the change in position. So if I start plugging in some of these numbers, my final speed was 3 meters per second squared. Oh, not per second squared, just seconds. And that will be squared. My initial velocity was 0 meters per second, and that will be squared. Plus 2, my acceleration was 9.8 meters per second, squared. And my change in position, well, my final position is unknown, but my initial position was 0. So if I put these numbers in, I'm going to get 9 meters squared over second squared equals 2. I'm going to ignore this 0 because 0 squared is 0, so I'm going to ignore that. So 2 times 9.8 meters per second squared multiplied by x. So if I multiply 2 and 9.8 together, I will get 9 meters squared over second squared equals, what is that going to be? That's going to be 19.6 meters per second squared multiplied by x. X is currently being multiplied by 19.6 squared, 19.6 meters per second squared. So to undo that, I'm going to divide both sides by 19.6 meters per second squared. So if I take 9 divided by 19.6 meters per second squared, I'll get my final position. X was 0.45, if I round up, 46 meters. Okay? Now, as I'm going to state right here, right now, I get that this can be tough. Okay? Not only are you using your motion equations, which is scary because you have to be able to plug in numbers, identify what you're missing, whether you're missing your initial position, initial velocity, final velocity, all these different things. You also have to sometimes combine equations together. For example, at the end there, I didn't have all the things I needed to use any of the equations, and I needed to find something that I didn't have. And I couldn't solve for time, but I could solve for acceleration because I had my summation of force in the x direction, and I used the force equals mass times acceleration equation at the end to find my acceleration, just so I could use this equation. Sometimes you have to use an equation to help you use a different equation, okay? That's the hardest part, I would say, for this entire unit. Now, with that being said, if you have any questions, please ask. I will do my best to address any concerns or any misconceptions you guys are having. Again, practice, practice, practice. That's what this is all about, okay? So with that being said, I wish you luck on your test. Reach out. Again, if you have anything else you want me to do, want me to help out with, or if you have any questions you just want me to answer, okay? Have a good one. Bye-bye.